Yeah.
Yeah. You can go ahead and get started.
hmm Okay. Yeah. Hello, everyone. And first of all, thank you for your valuable time today. And also, welcome to the UC San Diego EC recruitment event. So, yeah, I think it will be really good opportunity to introduce my research group and also provide enough information in case if you have any questions or if you need any clarification. Especially, I recently joined. I joined last November. So my website, the information, research information about my recent, the research might not be shown in my website. So this is actually especially a good opportunity for myself. So okay, I prepared, short the video, right? So can you please run the video? Mhm. Hello, everyone. I'm Mingu Kang and recently joined UC San Diego EC department as an assistant professor. Let me briefly introduce our group and current research directions. Our group focuses on vertically integrated VLSI information processing. So our group name is VVIP Lab. Our research goal is end-to-end VLSI implementation for machine learning and signal processing algorithms. As you have heard, so many different types of deep neural network models have been recently introduced. So we aim to design highly flexible and programmable architecture to support the wide variety of network models with high efficiency. We are also pursuing to achieve consistently high core utilization factor across various deep neural network models. In addition, we are also researching how to exploit the high data sparsity for better efficiency without messing up the regular hardware architecture. And also trying to achieve the scalability when so many such cores are connected in the large scale SoC design. In the mixed signal innovation theme, we are trying to carve out the digital core and replace it with analog core, which uses small voltage swing for significant energy efficiency. But all the interface will be maintained to be the same as digital without affecting external infrastructure such as program, instruction set, or compilers, so-called invisible analog core. Our group is also researching the data movement issue in the hardware. Emerging applications require huge data volumes, but unfortunately, the cost of memory access is several orders of magnitude higher than the computation due to the bottlenecks between the memory and processor. To address the issue, we proposed deep in-memory computing architecture, where the computation is processed at the moment of data access in the memory in the analog domain with low voltage swing for the energy efficiency. We are also looking for algorithmic innovation to enable always on chip learning to adapt for the temperature and voltage fluctuations and even real time changing input patterns in the highly resource constrained mobile platforms. Thank you for listening. For more information, please visit VBIP Lab website through the link below.
For more information, please visit ece.ucsd.edu.
Okay. Yeah, listening to my own, the recorded voice is really painful.
Oh,
Okay. So,
so if
yeah,
anybody
so
has questions, you guys feel free to ask, or you can type them in too, and I can read them to the professor. So go ahead. Or if you would like to share anything else about your lab, or I don't know,
Yeah,
any
right. So
information.
yes. So if you take a look at my website, most of those are focusing on the in-memory computing research part. But actually, recently I focused on a little bit different part, like a digital implementation and also mixed signal, but not in-memory computing. So still the memory and process are separated, but those are using mixed signal computing paradigm. So yeah, I'm researching, the digital and mixed signal balanced manner. So those might not be really shown well in my website. So I want to emphasize those. And also sometimes you're maybe you might be curious that how well our research groups the environment has been settled, because I recently joined. So the new research group, joining the new research group is sometimes students are really reluctant because of the poor environment setup. But I want to emphasize that you might not need to worry about that, because yeah, it's been 3 months since I joined, and I think that the algorithmic flow with the GPU and CUDA processor and the machine learning, the representative models like VGGNet, ResNet, or AlexNet, are so many different network already. I already trained and I already installed the server. I already installed all of the GPU-based training flow. Even the quantized network, I already completed the training. On the other hand, also the mixed signal flow, I completed the Cadence Virtuoso-based tool flow, and I installed the Virtuoso-based mixed signal flow and the Calibre-based layout tool flow as well. And PDK TSMC already completed all of the installation. And digital flow, I also set up the standard cell library, ARM standard cell library already. And genus-based script has been completed. And the only thing that I haven't completed is automated placement and route. That is the only thing that I haven't done. So in general, algorithmic flow and digital tool flow, and also the analog flow, all of those have been fully ready. So in case if you join my group, from day one, you would be able to start your own research immediately from day one, right? So I wanted to mention those parts, right? So in case if you have any questions, yeah, please feel free to ask me. And yeah, so I also joined for my MS degree. I was the second student in the group, so I had to yeah, spend tons of my own time to set up the research group. So I know what is your concern. I know exactly. So that is why I'm, the clarifying those factors, right? So there is no silly question. So please feel free to ask anything.
Hello.
Sure.
Hi, Professor Kang. My name is Walter. My question is regarding the AI acceleration research direction that you have in your lab. So I'm curious, so is your research tailored for a specific application, like domain specific, for example, like healthcare IoT, computer vision, or autonomous vehicle application, or only like more general architecture for AI acceleration? Thank you.
I see. That is a really good question. So earlier, I focused a little bit more computer vision applications, because the neural network algorithm has been focused on a lot, ImageNet or Cypher 10 or CBCL, the MNIST, that kind of things. But as time goes by, I'm also covering lots of the natural language processing part. The reason is the natural language processing requires really huge volume of data access. For example, transformer network or the BERT algorithm, the translator, from the French to Germany or Germany to Chinese, or that kind of a transformer requires really huge volume of data access. So I'm thinking that kind of thing is actually very good area for in-memory computing can be applied very effectively. So yeah, I'm focusing also the natural language processing And also I'm thinking I have interest in not only the neural network, but the other emerging machine learning algorithms. So those, sometimes the medical applications, recently I saw even the COVID data set as well. So I'm also thinking to apply those medical data set also, right? Yeah. Mhm.
Yeah, thank you for your answer. Actually, I have
Mhm.
one follow-up question. So
Sure.
let's say I'm really interested in joining your research, but I have no prior experience in VLSI research. So what do you recommend and what's your perspective about this?
I see. So in general, the certain student comes from strong background from algorithmic side, and certain students comes from really strong VLSI side. Even myself, I was Samsung, circuit designer earlier, and I didn't know anything about DSP or anything. But at least, based on that, my own strength, I started to learn very quickly. So if you have at least one strength, then I'm thinking that might not be a big issue. That can be, yeah, definitely overcome. Yeah, I think, right. Mm-hmm.
Yeah, thank you. Appreciate that.
Mm-hmm. Mm-hmm.
Okay, I think somebody had raised their hand. You can go ahead and ask your question.
Yeah, it was me, actually.
Okay.
Yeah, actually, I mean, Walter kind of touched upon it. So, yeah, and then I think you've answered it as well. Like, you find people from various backgrounds, and I think we can learn along the process and along the way. So that is a good possibility. And one interesting or one question which I had for you is why are you looking for okay, what is the intuition towards having analog course? And I think my idea would be, or I have one small idea that I have would be like probably exploiting approximate computation or something, so that you have you can train Bayesian neural networks or just random probabilistic models. But what was your intuition for replacing the course?
I see. Actually, your guess was really great. So the machine learning algorithms are usually quite error resilient. There is the inherent error resiliency because those are classification tasks, but that is not scientific computation, right? So there is a definitely error resiliency. And also, as time goes by, the people try to think about the quantized computation. So earlier at the beginning, they used the 16-bit and 8-bit, now 4-bit, even 2-bit. Most of the network, yeah, was possible. So analog computing is known to be very efficient in the low bit precision because in the low bit precision, there is higher noise margin, right? So in that regime, the analog computing is really effective. In addition, previously in the high bit precision computation, multiplication really matters. But as time goes by, the multiplication is less important, but the accumulation. So if you need to accumulate 1,000 values, your bit width of the accumulation should be large enough to prevent saturation, right? So, the accumulation, which is addition, the energy is started to dominate in the energy breakdown. So in analog domain is really suitable for addition. Why? Just charge, there is a charge in the capacitors and simply closing all the switches and charge sharing in one shot passive manner you can compute, right? So because of that, I'm thinking that. And also, I also have a lot of interest in the hyperdimensional, the vector-based, the neuromorphic computing. In that domain, the error resiliency is even greater, right? Though 25% of the bits are flipped, it computes properly, right? Then maybe if we really stick to digital, we are really failing to exploit the great opportunity, right? Yeah. Okay.
So we have a couple of questions in the chat. One of them, someone asked, what background is demanded in the research group? Is it helpful to have an experience in analog or RF or IC design?
Right. So yeah, uh, in the circuit design, there are two different vectors. One is analog and the other is digital. So if you do not have VLSI background, I would not recommend to research the analog area in my group. However, VLSI, especially learning the digital, that is not really complicated issue. You could learn the digital part quite quickly. So though you do not have analog background or RF background, if you have certain the amount of the algorithmic knowledge, that would be good, even though you do not have analog expertise. Right? So yeah.
All right. The next question was, I would like to know whether the lab will focus on error resilient application and incorporate approximate computing to tackle those.
Yeah, that actually, to some degree, that is really correct. I think that currently all of the companies have their own single core implementation. So especially the server version, everyone has already it. So some people say, okay, maybe the AI hardware research has been done. Someone says like that, but it's not really true because the academia is really focusing on mobile applications. Then, the mobile application, the server domain, the industry server domain, they have their own core and they are focusing on SoC. But in the mobile domain, let me ask a question. I'm using this kind of AirPod now. This AirPod can translate without relying on wireless connection. It is not true, right? So I think that until the point our research hasn't been done, right? Then in this mobile domain, we need some breakthrough to, create, really significant energy benefit, right? So, so maybe 10 times or 100 times better energy efficiency. Then I'm thinking that, just conventional way, it might be really difficult to implement the mobile, the learning and training and also communication in the mobile platform. So that is why I'm thinking the error resilient application or approximate computing is actually quite a good direction in my view. Right.
All right. And we had one more question and we have about 2 more minutes. So someone said, you mentioned in-memory processing through the areas you're looking for in machine learning acceleration. Would you also focus on new devices like, I'm not sure how to pronounce this.
Memristor.
Memristors in this regard?
Yeah, of course. Yeah, as you could see, actually, yeah, I'm from the PRAM team in Samsung. That is the earlier, the very promising new device before the Memristor became really popular. So naturally, I have interest. And indeed, actually, I'm collaborating with Professor Kyujung. She is device expert in the RAM area. Yeah, I'm actually already, collaborating with Professor Kyujung and also Professor Rosing, right? So yeah, that is actually, of course, I have a lot of interest, but one difficulty is fabrication is slightly difficult. But as time goes by, even the MRAM fabrication is possible in the global foundry, and RRAM is also possible. So yeah, definitely I will research more and also research really fabricate even the RRAM version, right?
All right,
So
so it looks like
time
we're
is
in our
almost up.
Yeah. All right. Well, thank you.
Okay, thank you. Thank you, everyone.
Thanks for joining us. Have a good evening.